So we have talked about delta S, or change of entropy, and we can say that delta S is actually a measure of randomness. The bigger it is, the more random. The bigger the value is, the more random the system is. Randomness also increases. Now, on the other hand, we have delta G, which is the degree of spontaneity. And actually, if we have a question of whether this reaction is spontaneous or not, we have to take a look at the delta G. In general, we can also say that delta G is also a state function. So again, we can also just take the final value minus the initial value, no matter how or which paths were taken to get from the initial value to the final value. So we can sort of use the Hess law here to be able to get the delta G, or to calculate the delta G from delta G's of different reactions that we can sum up. Now, there are two different ways also to calculate the delta G. So first one is the formula that I have introduced, which is delta G is equal to delta H minus T delta S. In the previous chapters, you've been introduced to delta H, and you know that delta H can be positive and it can also be negative. Now, in this case, if the delta H is positive, we call that the reaction is requiring energy to occur. And while if the delta H is negative, then we say that the reaction releases energy. So on the other term, we also use the endothermic here and the exothermic for the negative one. Now, we can find several combinations between delta H and delta S. Don't forget that a spontaneous process is the one that results in delta G being smaller than 0. And in this case, we can write down the delta H and also the delta S. Don't forget delta G is calculated from delta H minus T delta S, like this. We can have several combinations of delta H and delta S. We can have a reaction that is endothermic and gets more random. So there is an increase of randomness in the reactions. We can have the one that is endothermic, but actually becomes more ordered. So delta S positive is also more random, so higher degree of randomness, or negative, which is more ordered. And we can also, of course, have the exothermic reaction, more random, and exothermic reaction, more ordered. And we can see the trend for this each of these combination. If we have the delta H being positive, and if we have the delta S being positive, the only way for us to get a negative delta H, if this part is large enough to be able to get us a negative value, because delta H is positive, delta S is also positive. Something positive minus something that is also positive will only be negative if the one that we use for subtraction is large. Therefore, this combination of plus plus will be spontaneous at high temperature. Now let's find another combination. What if we have a positive delta H, so it requires energy, and a minus delta S? It requires energy and it becomes more ordered. Something that is positive minus something that is negative. Negative multiplied by negative is positive. So there is no way for us to get delta G negative, as we are summing up something that is positive plus something that is positive. So for this combination, it will always be non-spontaneous. Let's move on to the third combination, where we have delta H being negative and delta S being positive. So you can imagine something that is negative minus something that is positive. Any combination will result in the delta G being negative. So in this case, you will have spontaneous reaction no matter what. And indeed, this is the process that is liked or preferred by nature the most, where you have the delta S releasing energy instead of needing energy, and the delta S becoming more random. Don't forget the second law of the thermodynamics, that the universe actually tends to become more and more random. So this is the process. At any combinations of T, you will get a spontaneous reaction. Now let's take a look at the final combination, where we have both delta H and delta S being negative. So delta H is negative, delta S is also negative. How do we obtain a negative delta G here? Something that is negative minus something that is negative. Negative multiplied by negative, it will become positive. So something that is negative plus something that is positive then. In this case, the only way for us to get a negative delta G, if the T is low enough, we will get a value of delta G becoming negative if the T is low enough. So we can say that the final combination is spontaneous at low temperature. And this will be highly dependent on the reaction. Some of the reactions is the combination of positive delta H and positive delta S. Some of the reactions will be negative and so on. And from this, we will be able to predict thermodynamically whether a reaction is spontaneous or not, based on the value of the delta G. And if it is spontaneous, does the process prefer an elevated temperature or a low temperature? We can infer based on the combinations of delta H and the delta S.